All right, our fourth scenario is a little different. That one is just strictly on the x-axis. It's on the coordinate plane system. Okay, so if we draw the coordinate plane system, okay, and we sketch negative x to the fourth plus 3, that would be a parabola. Oops. That goes up to 3, and it's got to be negative. Okay. And it says express the area of a rectangle that's inscribed between the x-axis and that formula. Okay. Well, if I'm creating a rectangle that is inscribed between this formula and the x-axis, that would be like boom, boom. That is what it means to be inscribed inside something like that. The edges, the corner is on the rectangle, okay? Well, this point right here, coordinate points are just x comma y. Well, that means that it went to the right x units. And then if I went here, well, that went to left x units. But that still means that in terms of a rectangle, if I were to draw this out here, in terms of a rectangle, that means that that horizontal distance is a total of 2x, okay? The vertical distance, well, if you think about it, the vertical distance is your y. Well, we know what our y is. Our y is negative x to the fourth plus 3, which means my y value for the rectangle is negative x to the fourth plus 3. It wants us to find the max area. Well, area, is length times width. So that means that it's 2x times negative x to the fourth plus 3. Now all I got to do is distribute the 2x and then, take the derivative of it, set it equal to 0, find the test points, yada, yada. Okay, and so now if we take the derivative of that, and then remember you set it equal to 0. Take away the 10. Fourth root it. So then that means x equals the fourth root of 3/5. Okay? And it wants the max area. So now all you gotta do is plug that number into the area. You can just plug it into your calculator, your handy dandy calculator. And if you do that, if you do it correctly, you should get 4.22 units squared. And that is how you do mathematical optimization.